What's up, guys? Welcome back to the channel. As you can see here on the screen, we'll be doing this question paper, which is mathematics N4, and this paper was actually written on the 24th November 2025. It was an X paper that took 3 hours. So on this video, we're gonna only focus on question 4 because we already done question 1, 2, and 3. If you want to watch those questions, I will leave a link that has a playlist with those questions. You can watch the videos of those questions on that playlist on the description, and also on the top right of this video the playlist will pop up there. So before we continue, guys, I'm going to leave the timestamp for each and every question that you would like to watch, just in case you don't want to watch this question in a sequence order. All right, people, let's look at question 4 and then let's start solving it. All right, guys, here is our question 4. So as you can see, this question 4 has 5 questions and it is based on differentiation. So we're gonna be doing this question 4.1. So we need to create a little bit of space there before we do question 4.1. Okay, guys, here's our 4.1. So 4.1, they want us to differentiate y is equaling to 2x to the power of 3 minus 4 using the first principle. So we're going to derive using the first principle. So before you do that, you need to know the formula for the first principle. Let me just write the formula very quickly so that we can able to solve this problem. So it goes like this: f of x prime is equaling to limit h approaches 0, and then you have your f of x plus h minus f of x. All this is divided by h. You need to find your f of x plus h and substitute it there, and also you must substitute f of x. So what we have here is f of x. Let me show you what is our f of x. So our f of x is this one here, is given to us, so we are fine with f of x. So we can say our f of x is actually, the question there is 2x cubed minus 4. That is our f of x. So what we need to find here is our f of x plus h. So f of x plus h is equaling to 2. So wherever there is x, we have to substitute with x plus h. So x plus h to the power of 3. Let's not forget this x has the power of 3 there, minus 4. There we go. So this is how we're going to find our f of x plus h. But we are not done here. We need to factorize this part here, which is open bracket x plus h close bracket to the power of 3. So we need to factorize it. In order for us to factorize it, we need to use the binomial theorem. So let's continue. F of x plus h is going to be equaling to 2. So instead of substituting immediately, how about you write the formula of binomial theorem? So the formula goes like this: we have x to the power of n, the first term, plus n x to the power of n minus 1 multiplied by h, that is the second term, and the third term is going to be n multiplied by n minus 1, all this divided by 2 factorial. Let me write it: 2 factorial multiplied by x to the power of n minus 2 multiplied by h squared, close bracket, minus 4. So let me just highlight very quickly. So this part here is the one that needed us to use the binomial theorem. So this is actually the part here. There we go. So I'm just going to highlight as we continue so that you don't get lost when I'm substituting the values there. Before we continue, I'd like to let you know, guys, I've already done videos on binomial theorem. Just in case you don't know this formula, you can go to the description and click on the link of that video. Watch it in order for you to understand how the binomial theorem works and how to apply it. And the very same video will pop up on the top right of the one that you're watching at the current moment. Click on that icon and you can able to watch the video based on binomial theorem. So let's continue. When we continue here, we still have 2 outside the bracket. Then inside the bracket, we have x to the power of n. So the x inside the bracket here, it's actually x. So you're going to write x there. But n, it's actually 3 there. The exponent of 3, that is our n. So we're going to write to the power of 3 there. Now we are done with the first term. Now let's do the second term. The second term we have n. We already established that n is equaling to 3. And we have x to the power of n minus 1. So this is going to be 3 minus 1. So you can write as it 2. And then we have multiplied by h. What is h? H is actually h there. So you just write h there plus. So the third term, we have n, which is 3 there, open bracket. We have n minus 1. Remember, 3 minus 1, this is going to give us 2. All this is divided by 2 factorial. There we go. And then we have x to the power of n minus 2, which is going to be 3 minus 2 as exponent. This is going to give us 1. Even if you don't write anything there, it's fine. Multiplied by h squared, close bracket, minus 4. I know that some of you have to expand this to the fourth term. Yes, we expand this to the fourth term when they ask us to expand the expression. But here we are deriving using the first principle. So it's fine, people. You can leave it on the third term so that you can save time. If you're not comfortable in expanding this to third term, you can expand it to fourth term. It's also fine. You're going to get the correct answer. But I would advise you, especially on this type of a question, to expand your binomial theorem to only third term. So let's continue. If we continue, we still have 2 there. Now let's simplify what is inside the bracket then. Let me first highlight this. Remember, this is inside the bracket. We expanded this, guys. Do not forget. After opening the bracket, we're gonna drop this x cubed, and also we're gonna, the second term, we're gonna write it as it is. We have plus. Now the third term, we need to be very, very careful. We have 2 multiplied by 3 on the numerator, divided by 2 factorial. This here is gonna give us 3x multiplied by h to the power of 2, close bracket, minus 4. There we go. So we already simplified this one here. Let me highlight so that you can keep track that this is our x plus h to the power of 3. But let's continue. As we continue here, let me get rid of the bracket. So let me create a bit of space here. Let's get rid of the bracket. If you multiply this 2 with x cubed, we're going to have 2x cubed. Multiply this 2 with this one here, which is 3x squared multiplied by h. This is going to give us plus 6x squared h. If you multiply the very same 2 with another 3x h squared, this is going to give us plus 6x h squared minus 4, the 4 that we had there. So this here is our f of x plus h. There we go. Now that we find our f of x plus h, we can start substituting our values there on our formula. So let's go to the equation. Here's our equation here. So we're going to substitute our f of x plus h there and f of x there. So where are they? This is our f of x, and this here is our f of x plus h. So let's start substituting. All right, we're going to continue here on the right. So we have f of x prime is equaling to limit h approaches 0. There we go. So we have to substitute our f of x plus h and f of x. So here's our f of x plus h here. So we have to write all of it there. It's going to be 2x cubed plus 6x squared h plus 6x h squared minus 4. So this is our f of x plus h. Let's not forget it is minus by f of x. So here's our f of x, the question or the equation that is given to us on the statement. So let's not forget we have minus there. Here's our minus there, guys, just in case you don't understand. So make sure that you put it inside the bracket. As you can see, I've opened the bracket here. So you're going to put your f of x inside the bracket, which is going to be 2x cubed minus 4. Guys, do not forget to put it inside the bracket. It's very important. All this is divided by h. If you continue like this, we're going to have f of x prime, which is equaling to limit h approaches 0. Unfortunately, for f of x plus h, we're not going to do anything. We're going to write it as it is. We're going to have 2x cubed plus 6x squared h plus 6x h squared minus 4. We're going to get rid of this bracket and multiply by this negative 1 here before the bracket. So if you multiply negative 1 with 2x cubed, this is going to be minus 2x cubed. And we multiply this negative 1 with negative 4, that is going to give us positive 4. There we go. And then we divide by h. Now that we are here, we need to find the like terms. So let me highlight the like terms. Right, let's start with the first term. We have 2x cubed, which is positive. I'm going to highlight it with red. Here it is there, with another negative 2x cubed, this one here. They're going to cancel each other, that's for sure. We also have negative 4 and positive 4. They will have to cancel each other. So let's do it. This and that will cancel each other. Negative 4 and positive 4 will also cancel each other. So what we left here with is going to be 6x squared h and 6x h squared. So let's write f of x prime is equaling to limit h approaches 0. So we left with what here? We left with 6x squared h plus 6x h squared. All this is divided by h. Guys, to check whether you did the right thing on this step that we are currently in, you must be only left with terms that contains h. If it so happen that you have a term that does not contain h, you've made a mistake somewhere. Go and double check, especially here. Probably forgot to put the brackets there. So let's continue. As you can see on the numerator, we have two terms and both of them, they contain h. So it means we have the common factor. So if you continue, we have prime f of x is equaling to limit h approaches 0. If you take out the common factor on the numerator, we're going to have h. On the first term, we're going to be left with 6x squared plus 6x h. There we go. All this is divided by h. Right. Now, this h here on the denominator and that h there on the numerator, they will divide each other. So what you left with here is going to be f of x prime limit h approaches 0. Going to be left with 6x squared plus 6xh. Let me just create a little bit of space so that we can able to answer this. So from here, guys, we have to substitute h with 0 because our h is approaching 0. So let's continue. We have f of x prime, which is going to be equaling to 6x squared plus 6x. Wherever there is h, is going to be 0. Remember, h approaches 0. And whenever you do this step, you lose this here limit and h approaching 0. There we go. So our final answer, our f of x prime, is going to give us 6x squared. So this how you're supposed to do this question, guys. This question, it was not that difficult. It was actually simple and straightforward, but I would understand if you didn't manage to get this because of the binomial theorem. If this video helped you to understand how to solve this type of a question, do not forget to like, share, comment, and also subscribe to the channel if you haven't subscribed to the channel. But if you didn't understand, you can always leave a comment on the comment section and I'll try to help you to my level best. But we are done with this question, which is 4.1. We're going to do 4.2. All right, guys, here is our 4.2, right? So let's read the question. It goes like this: differentiate y is equaling to 3x squared multiplied by pi to the power of x using the product rule. So here we're gonna differentiate this expression here using the product rule. Now the product rule, it has a formula, guys. Again, let me write the formula for product rule. It goes like this: when you have y equaling to f of x multiplied by g of x, your answer, your dy over dx, is gonna be f of x prime multiplied by g of x plus f of x multiplied by g of x prime. So basically what you're doing here, you derive the first one and you leave the other on the first term, and the second term you derive the other one and you leave the first one. So basically that's what's happening there. So with this equation here, let me just write it here. We have y is equaling to 3x squared multiplied by pi to the power of x. We have two functions there that are multiplying each other. So that's the reason why we call it the product rule, because of that. So we can call the first one here f of x, right, multiplied by the second one here. Let's call it g of x. There we go. What you need to do here, the best thing that you can do is to derive these separately. So remember, I said f of x, in this case here, we say is equal to 3x squared. Now you have to derive this f of x prime. What is it? So we're going to use the standard derivative where we're going to have 6x there. Just in case you don't know about the standard derivative, there is a video that is based on the standard derivative. I will leave it on the description, and also the very same video will pop up on the top right of the one that you're watching at the current moment. Now let's do the other one, which is g of x. So g of x, we said is equaling to pi to the power of x. So when you derive g of x, before you drive it, this is an exponential derivative because x is the exponent there. G of x prime is going to be the following: pi to the power of x multiplied by ln pi. Right, so this is a derivative of the exponential function. Just in case, again, you don't know much about exponential derivative, I will leave a video on the description. Go and click on that video on the description, and the very same video will pop up on the top right of the one that you're watching at the current moment. So you can click on the icon on the top right there to watch and understand the exponential derivative. Now that we managed to derive f of x and g of x, it's time for us to use this formula here. So we can say dy over dx is as follow. Remember, we first derive our f of x. If you can see, the derivative of f of x is actually 6x multiplied by g of x. So our g of x is actually this one here, pi to the power of x. So multiplied by pi to the power of x. Then what do we do here? We add, right? Plus. Then what do we do? We write our f of x. Here's our f of x then, which is 3x squared, right? And then we multiply by g of x prime. Our g of x prime is this one here, which is going to be multiplied by pi to the power of x ln pi. So here, guys, it's our final answer. Just in case you got confused somewhere, just watch at the point where you got confused. If that doesn't help, leave a comment. I'll try to help you to my level best. But this was not difficult at all. If you don't know the product rule, again, there is a video of product rule I've made already. You can go to the description, click on that video, and also the very same video pop up on the top right of the video that you're watching at the current moment. Go and watch that video to learn about the product rule. So this is how you derive this equation here using product rule. I hope you guys managed to understand this. So if this video helped you to understand, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed. Right, people, we are done with 4.2. Let's go and do 4.3. All right, people, let's look at 4.3. Now 4.3, it goes like this: determine y limit x approaches 3, open bracket. In the numerator we have x squared minus 9 divided by, on the denominator we have 3x minus 9, close bracket. So they want us to find the limit of this problem here. So let me write it here so that you can able to see it clearly. We have y, right? And then they say limit x approaches 3, open bracket. We have x squared minus 9 on the numerator, and then we have 3x minus 9, close bracket. So they want us to find the limit of this expression. Yeah. So when you do limits, guys, you have to do the first step. So the first step, you need to do direct substitution. So since x is approaching 3, wherever there is x, we're going to substitute with 3. So let's do it. So I'm just going to do it here. On the numerator, we have 3 squared. Remember, x is approaching 3. Wherever there is x, we substitute with 3. Minus 9. Divide by 3 multiplied by 3 minus 9. There we go. If you continue here, we're going to have on the numerator 9 minus 9. That is going to give us 0. On the denominator, we also have 9 minus 9. That is going to give us 0. So when it's like this, this is actually infinity. We need to do the second step. Now, the second step, guys, is to do simplification. Can we simplify this expression here? When I look at it, yes, we can. So let's do it. Y limit x approaches 3. let me just say equaling to them. Now, if you look at the numerator there, we have the difference of two squares, guys. So the difference of two squares is going to be x minus 3 and x plus 3 when you factorize it. And then underneath there, we have the common factor, which is 3. If you take out 3 as a common factor, we're going to be left with x on the first term minus 3 there. Now, if you can look there, we have x minus 3 and another x minus 3 there. So what we are left with here, we are left with y limit x approaches 3. And then you only left with x plus 3 divided by 3. That 3 there. There we go. So when it's like this, we can do direct substitution. So let me do it then. Wherever there is x, I'm going to substitute with 3. We have 3 plus 3 divided by 3. So 3 plus 3 is going to give us 6. Divided by 3, that is going to give us 2. So guys, this is our limit. Our limit is actually 2. Guys, just in case you don't know how to do this limit, again, I've done the videos on limits. Go to the description. When I leave a video that is based on limits on the description, click on that video, and also the very same video will pop up on the top right of the one that you're watching at the current moment. Go and watch those videos in order for you to understand limits. All right, people, we are done with this. If you didn't understand this question, please rewatch at the point where you didn't understand. Again, if this doesn't help, you can leave a comment in the comment section. But if this helped you to understand how to solve such problem, don't forget to like, share, comment, and also subscribe to the channel. Since we are done with this, let's go and do 4.4. All right, guys, let's look at 4.4. They want us to differentiate this expression here with respect to x. So let me rewrite it so that you can able to simplify it. So we have y is equaling to open bracket and another inner open bracket x to the power of -1 plus x close bracket squared open bracket multiplied by root x. So this is what they want us to differentiate. As you can see, this here, it needs us to simplify it further before we differentiate. Guys, you cannot differentiate with this type of expression like this. You need to simplify it further. So let's start. Y is going to be equaling to open bracket, the outer one, and then we also have to do this one inside them. So write this x to the power of -1 is 1 over x plus x close bracket and then open bracket. Remember, we have squared there, so let's repeat it. It's going to be 1 over x plus x close bracket. We close the bigger bracket. Instead of writing the square root of x, we can write x to the power of half. It's very important for you to change this as well. Let's continue. Now we're gonna open the bracket, so we also want to open the ones here. You have to do FOIL. If you multiply 1 over x with 1 over x, you're gonna get the following: 1 over x squared. If you multiply 1 over x with x, you're actually gonna get plus 1. There we go. Then we come to this one, you're gonna get another 1. There we go. And then when you multiply x multiplied by x, you will be getting x squared close bracket. Then this one here, we have x to the power of half. There we go. Then from here, we have to simplify the ones inside the bracket. So let's continue. As you can see there, open bracket, we have like terms. We have 1 and 1. So 1 and 1, they're gonna give you 2. So we can write this as 1 over x squared plus 1 is going to be 2 plus x squared. There we go. Multiplied by x to the power of half. Again, we are not done. We need to get rid of this here. Before we get rid of the brackets, we need to rearrange this. We can write the first term here as x to the power of -2 plus 2 plus x squared. All this multiplied by x to the power of half. So let's get rid of the brackets. So if we get rid of the bracket, we're going to multiply this x to the power of -2 with x to the power of half. Guys, we have to use the exponent laws here. When you multiply x to the power of -2 with x to the power of half. Since the base are the same, the exponent will add. So basically, here's what is going to happen. It's going to be x to the power of -2 plus half. So this is going to give us x to the power of -3/2. There we go. We continue. We multiply this 2 with that x to the power of 1/2. This is going to give us 2x to the power of 1/2. And then we do the last term here. We have x squared multiplied by x to the power of 1/2. Again, let's do it here. X squared multiplied by x to the power of 1/2. Remember, the base are the same. The exponent must add. So we have x to the power of 2 plus half. So this here is going to give us x to the power of 5/2. So we're going to write x to the power of 5/2. All right, so before you continue, some of you are confused. How do I get to this point here? These are exponents law, guys. Just in case you don't know much about exponents law, there is a video where I explain all these exponents law. I'm going to leave that video on the description, and also the very same video will pop up on the top right of the one that you're watching. All right, people, let's continue. So when it's like this, we can able to derive. So I'm going to do it here on top. Dy over dx. All this term, you're going to use the standard derivative. So if you still remember, the standard derivative goes like this. Y is equaling to x to the power of n. If you derive this, dy over dx is going to be n x to the power of n minus 1. So that's what you need to do. Let's start with the first term. There we have x to the power of -3/2. So we have to first multiply by that -3/2. And then we have x to the power of -3/2 minus 1. That's the first term there. Plus. And then we have the second term. We have 2x to the power of half. So here we have to multiply by 1/2 inside the bracket, which is our exponent, multiplied by 2x to the power of half minus 1. So it's going to be half minus 1. There we go. And then the last term, we have x to the power of 5/2. So we're going to multiply by 5/2. And then we have x to the power of 5/2 minus 1. So let's simplify this further. Dy over dx. This here is going to give us -3x. What is the power when you have -3/2 minus 1? This here is going to give us -5/2. All this is divided by 2. And then we continue here. Plus, we have this 2 and that 2. They will divide each other. So we're going to be left with x. What is the power of half minus 1? It's going to give us -1/2 as the exponent. Plus, now we have 5 multiplied by x to the power of 5/2 minus 1. This here is going to give us 3/2 as the exponent. All this divided by 2. Right. So this is our answer, but never leave your answer with negative exponents. So let's change our exponents to positive. So dy over dx is going to be -3 divided by 2. Since we change the exponent, which is -5/2, we can make it to be x to the power of +1/2. Remember, if our exponent becomes positive, the base, which is x, is going to be on the denominator. Right, so let's continue. The second term here, we have x to the power of half. We can write 1/x to the power of +half. There we go. And the last time we changed nothing there because our exponent is positive. So we're going to have 5x to the power of 3/2 divided by 2. There we go. You can go further. By the way, this is the answer. But if you decide to go further and leave the answer in SATs, you can write the following. -3/2 multiplied by root x to the power of 5 plus 1/root x plus 5/2 root x to the power of 3. So you can leave your answer like this. It's still fine, people, but this one as well, it's accepted. Guys, if it so happened that you didn't understand how to do this question, please do not forget to watch at the point where you got lost. And if that doesn't help, people, leave a comment in the comment section. I'll try to help you to my level best. But if this video helped you to understand how to solve such problems, you can like the video, share the video, comment on the video, and also subscribe to the channel if you haven't subscribed to the channel. All right, people, we are done with 4.4. Let's go into 4.5, which is the last question of question 4. All right, guys, here's our 4.5. Now, 4.5, we are given this expression here, or the function. We have f of x, which is equaling to x cubed minus 2x squared minus 8x. Now, they want us to calculate, using differentiation, the coordinates of the turning point and the point of inflection, and also distinguish between the maximum and the minimum turning point by using the second derivative. So this question here, they want us to find the turning point first, point of inflection, and distinguish between maximum and minimum turning point using the second derivative. Right. So whenever they ask you to find the turning point, guys, you first have to derive this equation once and equate it to 0. So let's do it. So if you say f of x prime, it's going to give us, the first term is going to be 3x squared minus 4x minus 8. So this here is the first derivative, and it's going to be equaling to 0. So when it's like this, guys, this means that you need to solve for x. So when you solve for x, unfortunately for this one, we need to use the quadratic formula. So let's do it. So it goes like this: x is going to be equaling to negative b plus or minus square root of b squared minus 4ac divided by 2a. Right, so this is what we have there. Now, for those who don't know, in a trinomial, we have the coefficient, which is going to be a. In this case now, it's our 3. And then the coefficient of x is going to be negative 4. And the constant there, which is going to be negative 8. Right, so we have to substitute those coefficient and the constant in our equation there. So let's do it. We have x, which is going to be equal to negative b, but in our case, negative b is going to be negative 4. There we go. Plus or minus, and then we put it inside the square root there. So that is going to be negative 4 squared minus 4 multiplied by a, our a, which is 3 there, multiplied by c, or c, which is negative 8. And then all this is divided by 2a, but a is 3. There we go. So from here, we can use a calculator. Let's start with the first one here, negative and negative. This one is going to give us 4 plus or minus. So let's write our root here. So what we have inside the root there is going to be 112 divided by 6. So let's write 6 here. Let's continue here on the top right. We know that we can write it like this: x is equaling to 4. Remember, we have plus or minus there. We can start by saying plus, and then we have the root of 112 divided by 6, and x is equaling to 4 minus, instead of positive this time around, square root of 112 divided by 6. There we go. Now if you put this on a calculator, what I'm getting there is 2,431, and the other x is gonna be equaling to negative 1,1. So these are our x's when we use this equation there, or when you solve for x equation here. So we need to find the y coordinate of the turning point. So we can continue here and say when x is equaling to 2,431, what is our y? There we go. What is our y? What you're going to do to find y, we need to use our original equation there from the statement. Wherever there's x, we're going to substitute with 2,431. So let's do it. So we have x cubed. Instead of writing s cubed, we're going to write 2,431 cubed minus 2x squared. Instead of writing s squared, we're going to write 2,431 squared minus 8x. Instead of writing x, we're going to write 2,431. There we go. Put this on your calculator, then we find our y value. So what is our y value? It's going to be negative 16,9. Right, so we already find the value of y when x is equaling to 2,431. So we can call this one turning point 1. Let's call it TP1. So x is going to be 2,431. Y is negative 16,9. There we go. So this is our turning point 1 when x is 2,431. But when x is equaling to negative 1,1, what is our y? There we go. So very simple. We're going to do similar thing that we did on the first turning point. We're going to use the original equation. We know that y is going to be equaling to, instead of writing x, we're going to write negative 1,1 cubed, then minus 2 negative 1,1 squared minus 8 multiplied by negative 1,1. There we go. Put this on a calculator and then you get the following. Let me first create a space. Y is going to be equaling to 5,049. So turning point 2 when x is negative 1,1, or y is going to be 5,049. There we go. Now we already find the turning point of this. It's time for us to distinguish which one is maximum, which one is minimum between these two turning points. Now, I need you to listen very, very careful, guys. When you try to find, or when you try to distinguish which one is the maximum and which one is the minimum, you need to derive twice and substitute the x value of the turning point. So you need to derive twice and then substitute these values here on that second derivative, and then when your answer it's greater than 0, just know it's a minimum turning point. And then if the answer is less than 0, just know it's a maximum turning point. So let's do it. The second derivative is d squared y over dx squared. Remember, the first derivative we had 3x squared, so this is going to be 6x minus 4. There we go. So what you're going to do here, we're going to substitute our turning point. Again, when x is equaling to 2,431, let's substitute them. So d squared y over dx squared. So wherever there is x, we're going to substitute with 2,431. So let's do it. We have 6, 2,431, close bracket, minus 4. What do you get there? I am getting 10,586. So this is greater than 0. So it makes this one to be minimum. So you can write this turning point here, it's minimum turning point. Now it's time for us to find the maximum turning point. So we're going to do the same thing that we did here. We're going to substitute the x value on our second derivative there. So let's do it. So d squared y over dx squared when x is equaling to negative 1,1. This one here, guys, just in case you didn't understand. So it's going to be equaling to 6. Instead of writing the x there, we're going to write negative 1,1 minus 4 there. And then our answer is going to be negative 10,6. As you can see, it is less than 0. This makes it to be maximum turning point. So you can write here maximum turning point. So this is how you distinguish between the maximum and the minimum turning point. I hope you managed to understand this. Now we have the last question there, which they want us to find the point of inflection. So let's find the point of inflection. Now let me create a bit of space here so that you can able to find the point of inflection. Guys, when you find the point of inflection, your second derivative must be equaling to 0. If you still remember, our second derivative, d squared y divided by dx squared, was equaling to 6x minus 4. But then this must be equaling to 0. And then you start solving for x. Usually when you calculate for a point of inflection, the second derivative must be equaling to 0. So in order for us to solve for x, we need to transpose this negative 4 to the right hand side. We're going to be left with 6x is equaling to 4. And then we divide by 6 there, we divide by 6 there. So x is actually equaling to 2 over 3, or 0,667. So this is our x coordinate for the point of inflection. Now the y coordinate, we're still gonna have to take the original equation. Our original equation, we have y is equaling to x cubed minus 2x squared minus 8x. So this is our original equation. So in order for us to find the y-coordinate of the point of inflection, we substitute by our x-coordinate them. So let's do it. So wherever there is x, we're going to substitute with 2 over 3, and then we put cube them minus 2, and then we have 2 over 3, and then we have squared there minus 8, and then we also have 2 over 3. If you put this on your calculator, we're going to get negative 5,926. So this here is our y coordinate. So point of inflation, the coordinate go like this. We have 2 over 3 for x, and for y we have negative 5,926. There we go. So here is everything on that question. So guys, this is how you do this problem here. Let me try to zoom down. Maybe we can able to see all the problems, but it was not that difficult, people. This is actually straightforward. All you have to do is to find the turning points by differentiating once for x coordinate and substitute those x coordinates on the original equation. You get the y coordinate, and then you check or you distinguish between the maximum and the minimum by the second derivative and substitute the x values. And when you get the negative answer, just know it's a maximum, and when you get the positive answer, just know it's a minimum turning point. As for the point of inflection, you derive twice and you equate that derivative with 0. You solve for x, you get the x coordinate. Take the very same x coordinate, you substitute on the original, you get the y coordinate. So that will be the coordinate of the point of inflation on this question. Guys, if it so happened that you didn't understand this question, please do not forget to leave the comment on the comment section. But before you do that, watch the video at the point when you get lost, and if that doesn't help, that's when you can leave a comment. But if this part of the video helped you to understand this type of a question, do not forget to like, share, comment, subscribe to the channel if you haven't subscribed. Guys, we are done with question 4. We'll be doing question 5 soon, so make sure that when you subscribe, hit the bell notification so that whenever I upload a video, you get notified. Thank you very much, guys, for watching. Till next time, cheers.